Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 370. Maximum balanced subsequent sum. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one is a very kind of annoying, tricky one. There is one trick that I think a lot of more, like we look at the leaderboard, a lot of them are kind of top or like they've been around the circuit. And we haven't seen it before. I don't know if it's impossible, but it's very hard. And I mean, if you have mathematical background, I don't know if you kind of see it before, but whatever. Because I think the first time I've seen it, it took me like I just didn't get it. Not gonna lie, but yeah, but the core idea is that okay, so you have this number, right? Or you have this formula. Ooh, spoiler alert! Close your eyes. Close your eyes. Yeah. Okay. So you have, let's say you have this, right? Um, I sub j, is it I sub j, right? Yeah. That's a yeah. Anyway, so something like this, right? And the idea here is just minus I minus j on both sides, right? Da-da-da-da-da. And then minus this on both sides, right? Da-da-da-da-da. And then change the signs and then do something like this, whatever, right? Wait, is that right? Did I mess something up? Oh no, it was it's plus this on that side, so it's plus, so then this was, oh, maybe I just kind of confused. Wait, did I? Yeah, in any case, so you get something like this, right? And this allows you to kind of what's the term? This allows you to kind of basically focus each number by itself. So now you don't have to worry about two numbers and the relationship to each other, right? And basically, n is 10 to the fifth, so you have to do something like this because obviously n squared is going to be too slow. So yeah, so once you kind of index this, the idea is basically just that, yeah, I mean, this is literally the core idea, right? Is that basically you have this, for each number you calculate this thing, and then the next number you have to try to calculate the next or something that's bigger than it, right? I mean, I kind of wrote this in a I mean, it's just the way that it was set, wrote it. So you have something like this, right? And then you just kind of keep going, obviously incremental from each one. Um and and this is where I kind of thought about this problem of that, given a subsequence, I thought along the lines of longest increasing subsequence, because now we could be like, oh yeah, now we could just do a longest increasing subsequence, and of course that's gonna, but the that's gonna be, there is an n log n solution, so that makes it okay, right? But then I thought that, but then it didn't really quite work out because it is not greedy in the same way. Because longest, you can always be greedy in that, well, how do you make something longer? By something long, by taking something that's very long and then make it longer, right? And add one. So I kind of thought about that way, but it doesn't really work on this one because you can have negative numbers, right? And here, you actually don't want the longest subsequence. And even if you didn't have negative numbers, you don't necessarily want the longest subsequence anyway. You may have just like one big number in the front that, or something like this, and you just take the one number because you want the sum. So what can we do now, right? Well, to be honest, I play around with the idea a little bit, and the way that I thought about it is just, in a way, dynamic programming, but based on these index, right? So how would I write this in a dynamic programming way? And here, this is just for visualization. I actually didn't do this visualization during the contest because I kind of did a different visualization, I'm not gonna lie, but I thought this would be a good idea. Right? Because I think this is a better visualization, right? And the idea here is that, okay, so let's say you have 4x, right, in range of, let's say we have 4x in the input, right, nums, right? And then now what? And of course, let's say you have an index, so let's say I and x and index, right? And then basically what you want to do in a naive way is just look at all the previous numbers, right? So for let's call this, yeah, for previous j, y, and enumerate previous stuff. We want to see if x minus I is greater than equal to was it y minus j, then we know that we want to set it up so that in the future x sub I is in a good place. So then maybe you have something like dp of x minus I is equal to the max of dp x minus I plus this, or dp of y minus j plus x, right? So this is kind of the dynamic programming solution, and of course you take the max over all the dp's, and the previous you kind of just insert, I don't know, whatever, right? Previous dot append ix or something like this. It doesn't matter, right? And this isn't, I mean, I know that this is actual Python code, but this is meant to be pseudocode, so don't hold me to it. But that's basically the idea, right? And of course this is going to be n squared, right? Because this is n, this is O of I, so then you have the summation of 1 plus 2 plus 3 plus 4 ... to n. That's n squared. And yeah, right? So this is n squared, this is too slow, right? So what can we do? Well, there are two things, right? One is that now, so we only look at y minus j's that are smaller than x sub I, right? So that kind of hints to me a sort of a range query, right? And basically it's just looking at all the numbers that are smaller than x sub I. So if we can get, and if you look at this, we can actually take this out a little bit, right? So we can, and what I mean by that is that we can, how do I say this, right? So we can take this out of the loop in a way. We can just write max of dp of y minus j plus x, right? Over all these other previous ones. And of course, in this case, we can take out the plus x, right? So then now dp sub x minus I is just equal to max of, well, just max of itself. So this is a weird way of writing it, but of this plus this, right? And of course, you can rewrite this max as an if statement, so we'll just ignore it for now, right? So we can just set it to this, right? And like this is in real code because this is max over or like max over or y or jy's, right? So you could write this in a one-liner. I kind of wrote this in a weird way, so I don't even know if this is true. But basically, you would have written something like this, right? Right. So yeah, you have dp y minus j. If you want to consider it as real code, something like this plus x, and then right is equal to this, kind of, right? You still have to do an if statement of whether this number is bigger than or whatever, right? This is more Python code, but like I said, this is still pseudocode. And what does this remind you of, or what can it remind you of, right? Let me rewrite this real quick, right? And of course this is still n squared. I don't think this is real code, but maybe it works just by coincidence, right? So the thing is that we know that, like I said, this is a range query. So basically we just want to get a max of a segment from, I guess, everything to the left of it to smaller than x minus I. So it's to negative infinity to y minus j, right? To x minus I, right? So negative infinity to x minus I, and you do a range query, you do a max query, and that's pretty much it. So now, when you do a max query, then now you can do this thing plus x. And then now you update x minus I so that in the future, you can search for it in a different query, right? So that's basically the idea. If you are able to do this in log n time instead of O of n times, then this will be n log n. And it turns out there are a couple ways to do it. I'm not a fan in general about these kind of problems on Leetcode for interviews. But basically, you could do it with segment tree or binary index tree, and there are probably other trees or whatever. But that's the idea, because you need two things, right? You need max over a range, and then either update increment over a range, right? Whichever is fine. I think, yeah, whichever is fine, right? But yeah. And that's basically the way that I did it is with binary index tree, or if you Google it, it can also be framework tree. And then we'll go over the logic in it, and yeah. And the logic is pretty. One thing that I did have to do, of course, is that all the numbers are negative 10 to the 9 to 10 to the 9th. So I re-indexed, we normalize the number so that it becomes from 0 to 10 to the 5th. So that basically, like, the smallest number, I replace it with 0. The second smallest number is 1. The third smallest number is 2, dot, 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 right? And you can see that here. So I made it into a set. So for ix is s, I add this, and then I sorted it, and then yeah, and I sorted it, and I made the lookup based on it on index order. I create a binary index tree, and here, this is basically what I mentioned, right? So because 0 is the smallest number, so you basically want to get the max query from 0 to this index. So then here, as we said, we get a max, and then the current, we update it to either x, which means the number by itself, or the previous number, because in that case, in either of these cases, you take x if current is negative infinity or some negative number. You take x if current is a negative number and x is a smaller negative number or something like this, or current plus x, meaning if you combine them, usually they're both positive numbers, so that makes it that. And then you update that to the tree, and you also check that against the best number you have seen so far. And basically, this means the number that ends with this number, or sorry, the subsequence that ends with this number. And I'm not going to go over binary index tree in this video because it would probably take too long, and I'm really tired anyway. So definitely there are good resources out there, so definitely important to look into those. But yeah, this is my binary index tree. I actually have a template for this, and I had to update. I had to Google a little bit because it's been a while since I did a max binary tree, and there's some modifications that I had to do, but this is my max binary index tree, and yeah, and that's pretty much it. Complexity, this is going to be O of n because of this, and also this chunk. In terms of your time, this is going to be n log n. This is an O of n loop, and we do 2 O of log n queries. So n log n time, O of n space, and that's pretty much it. I'm going to show you the top again and the bottom again, and yeah, you can watch me sub it live during the contest now. Hopefully we don't mess up too much. Okay, good. That was kind of hard for Q3. How am I doing in time? 46, not bad, not fast, but okay. I mean, I had the idea, but it's just kind of so many things to think through. Anyway, Q4, let's go. Maximum balance subsequence sum. Subsequence is balance if it holds. Num sub j minus num sub j minus 1 is greater than so the numbers are greater than indexes, right? What is n? N is big, so we have to think about it. Oh, it's the sum of the elements. And people already gotten it? People are so good. Oh, excuse me. Oh man, should take a nap. Okay, so the first thing to know is we have to do the trick, right? What's the trick? If you have something like this, this is ugly, but maybe understandable. I'm slowing down a little bit, but yeah, and you want to change the thing so that minus this on both sides, and then add subtract this from both sides, right? Something like that. And then yeah. Anyway, but so then yeah. So what does that look like after we converted this, right? For full explanation, watch the explanation video. I'm still just working out in my head, right? So that means for ix in nums, print x minus I. I just want to visualize this. That's what I'm doing now, and it's going to give me an error just now. They actually do a thing, but before we turn value, oops, enumerate. So 3 2 3 3, right? And then the next one is 5 1. What is the 13? Because it's 5 and 8. So then it's 5 and 5. And I think this is, as long as it's increasing, is it that it is increasing? Because the 2 is increasing, but 2 and 5 is no. Oh no, this is 5 is good too, right? So then now it just becomes longest or not longest, but the total increasing sum of this thing. Okay. That's tricky though, isn't it? I mean, basically, now you could do an LIC for the longest increasing, but I have to think about how to do it for the longest something, right? And also clearly this does not. Oh, I mean this works. They are balanced. It's just that because of negative numbers, you only want one of them. So it's not just the longest. We do have to figure out how to get this to sum in a good way, because this 5 and this 5 is good. Actually, the -2, -5, and 5 is good too. So it is. So we have reduced it to LIC, longest increasing subsequence. But how do I do the sum of? So it's not the longest increasing. It is sum of increasing. So -2, you're trying to find the last -2. Is that is it just as straightforward as you think, or am I just confused? Let's play around with it then, right? So okay, so you have the LIC array is right, and then now you want to binary search on x sub I, right? So left, yes, and then we want it to be a tuple. It's not quite true though, right? It is not quite true that you want the longest increasing because of the negative numbers. Can I do anything about the negative numbers? People have gotten it though, so it's not like, I mean, it's not easy, but people seem to be getting it. A -1 is not enough of a sentinel value, but So what am I biasing? So there's that, and then basically you're just trying to say it is not the longest though. I think that's the part that I'm struggling with. So you're trying to, okay, so what are you doing? You're binary searching on things that ends in -2, and then you max that. So if you add a -1, it just won't do anything. But because the greedy doesn't help here, right? Or at least the greedy with respect to the length. How would I do it? And even this, right? So let's say this was a 4. Actually, that would just be whatever. But let's say this was a 2. Or even let's say this was a 2. Then how do you pick the 3 instead of the 2? Right? Because if we have this, we want to. Oh, whoops. Yeah, whatever. Did I not print? No, I did not print. Yeah, so then this is 2, 2, 3, 3, but you actually want the 3, 5, and 6 to get the 14 instead of 2, 5, and 6, right? Okay, so what am I doing? So, okay, so we set 2. Okay, so let's say we do all these, and then we normalize it to 10 to the 5th. And then what does that mean? That means that we're trying to figure out are we trying to figure out the max of all the numbers of 3 or less, and then update 3. So the max of the prefix, and the prefix we can do with binary index tree. Am I kidding me? Is this the way to do it? I think it is. Or I don't know if this is the only way to do it, but it is our way to do it. You can't see me doing some cheating right now. No, and by cheating I mean I'm just looking at my binary index tree things. Okay, so I have right, and then we have to renormalize this, right? So what are we doing? We want to renormalize x sub I, right? So okay, yeah, sorted is good, right? Or set maybe. I, right? And then for x in list of, I think this is sorted already, but I just want to I like writing it this way, right? So then we want to enumerate this to lookup of x is equal to I, right? So then now this x is different than this x is very confusing. I know. I'm sorry. And then now we have tree as you go to let's just say n plus 5 because I can't count. I always forget how to do these. And this is a total binary index tree. I want a max binary index tree. Right? I could do that, right? That's not a thing. Let me Google this. Getting Japanese results because I'm in Japan, which is interesting anyway. Okay. I'm not gonna lie, I thought I knew this, but I just wasn't sure. I'm not sure that it generalizes from max. If not, then we have to use a segment tree or something. Yeah, it's been a while. I mean, it's either that or another segment tree. We could use segment tree. But, okay. I have to actually learn segment tree, but yeah, so this is get max, right, of I, so I think this is, and this is actually negative infinity, right? I think that's fine, and then otherwise, how do I do updates there? I mean, that part I kind of knew, but well, we only update if it gets higher, so right, so yeah. Nope. I think this is right? I don't know. I have to kind of is that true? I don't even know my API anymore, but we have plenty of time, I think. Well, that's not good. Because this should be, oh. Increasing is not quite right. Or like, we have to increase. Oh, okay. Maybe it's fine. Maybe I just need to get the variant and replace it. It's a replace, not an increase. Okay, fine. Update. Okay. All right. And then now what are we doing? Okay. Right. So then now for each number, best is equal to, I guess, negative infinity. So now we look up, and actually this 0 as well, right? This is actually negative infinity as well. We want to get the, okay, so index is equal to x minus I, lookup of this, right? Let's make sure that it doesn't give me like any outbounds everywhere. Okay, so then now we want the tree get max of index, right? So the current, so this is the current sum is equal to this, right? So if x is greater than 0, yeah, if x is greater than 0, then current sum we add it to x, and then we do an update. I guess if it doesn't, then we don't update. Actually, is that true? No. I mean, it is kind of true, but actually we want to do this first. Because this could be negative infinity plus... Actually... Yeah. Okay, so it's either this tree dot update of index, set it to current, and best is you go to max current best, or else if this is negative, we don't want to add it, but if this number is less than it, then that's good, right? So current is you go to max of x and current, tree dot update index current, and I guess this part actually overlaps, and then we return best. Is there like a -1 thing to do? Not possible. Yeah, because I'm returning something like this, but I shouldn't though, right? Because I should always return at least one number. I am returning some ridiculous number. Oh, so I see. Max of x current and current plus x. Actually, maybe I guess I could do this all the time. Oh, oops. 14, 13, -1, and I mean it matches. That's YOLO. Is there like 0 element or something weird? Alright, good. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.